Good evening, good evening, and welcome to Paying Taxes for Fun and Profit. I'm sure that you all fill out your income tax returns properly for the joy and profit of your respective governments, but that's actually not the kind of taxes I will be talking about today. I will be talking about the taxes that we pay as developers, stuff we do that doesn't actually add functionality to our programs, but we sometimes have to do them anyway. And these are taxes that you pay to varying degrees. If you make a tic-tac-toe program for yourself in your basement, you don't have to pay any taxes whatsoever. If you create an internal website for your company, you may have to pay some. And if you want to make a program that's sold across the world, you'll pay a lot of taxes. So how much tax you need to pay and what kinds of taxes you need to pay depends on your product, your market, and to an extent who you are as well. As a rule of thumb, the bigger you are, the more taxes you have to pay. Paying them can be profitable, and perhaps surprisingly, some of them can actually be quite fun as well, or at least interesting. That's what I hope to convince you of today. So one too much. A different word for these taxes might be horizontals, or you might call them non-functional requirements. They're all things that we do that do not add any new functionality to your program. But if you want to have an international market to distribute your program abroad, you need to do something about internationalization one way or another. If you want to sell your... Sorry about that. I don't think I'll repeat everything. I hope you caught most of what I said as an intro, but it was just an intro. Just arrived at internationalization. If you want to sell to government, you almost certainly have to do something about accessibility because it's a requirement. And if you're a decent human being, you will do something about accessibility even if you're not selling to government, because people actually need that to be able to use your product. If you want to know how many people are using your product, you might want to have some telemetry. If you want to find out why your program is crashing, you want telemetry, and so on and so forth. This list is incomplete, partly because the demarcation line between taxes and non-taxes are quite fuzzy. And you could, for example, make an argument that testing is a tax. Since some of us are sort of subscribed to test-driven development, which I do up to a point, that sort of doesn't make any sense. I'm not going to make that argument, but you could make it. So let's start with internationalization. This is usually divided into two different parts. One is globalization and the other one is localization. And the first one deals with how you display things like, for example, dates in a format that's understandable and expected by users across the globe. Whereas localization is the process of making your user interface available in different languages. And the two of them are quite distinct, but the border between them is quite fuzzy, especially regarding string handling, which they both sort of appear in both of them. So let's have a look at globalization, all the formats that we use and how different they are. String handling is a bit of a challenge. Character sets. Back when I started doing software development, it's a while ago, we had ASCII and EBCDIC. And that was about it. So when we did programming, the letters A, Ö, and O, which appear in the Norwegian alphabet, did not appear in the computer output because they simply weren't there. There was no such thing as non-ASCII characters in software development. Actually, my development environment looks like this. Back then, it was a stack of cards that you fed into a card reader, and after about half an hour, a huge printout would come out the other end. Happily, we have advanced somewhat since then, and with regard to character sets, the solution we have come up with is Unicode, and that's probably what we're going to live with for the foreseeable future. which makes localization and globalization possible. It doesn't necessarily make it easy because this is a really complex matter, but it certainly is possible. The other things that fall under globalization would be date and timestamp handling, how we deal with numbers, and how we deal with currencies. So let's look at strings. First of all, it's the representation. In the Unicode, the A with an accent can be represented as a single code point, or it can be represented as an accent with a letter A following it. And it should display the same, but the representations are different. And that means if you do any string processing in Unicode, you should try as best you can to avoid ever using or accessing single character, because they don't necessarily make sense out of context. So whenever you can, use strings or substrings for all operations that you do. Then they had ordering, which is clearly culture specific. This is an example of culture dependent ordering. The left column is English and the right one is Swedish. And neither of these languages have any concept of the letter A, which we have in Denmark and Norway. So they interpret that as a ligature, AE, and sort it under AE. When you get to the O, the A with the ring over it, the American alphabet has no clue what that is. It thinks it's an A with a ring over it, which it is. So it ends up with the A's. Whereas in Sweden, it is actually the 27th letter of the alphabet, and it ends up at the end. So those of you from Norway might be surprised that Sweden has this character at number 27 instead of where it should be at number 29. But, I mean, they're Swedes. What can you expect? Yes, casing. That's a cool one. The letter I, we usually have a lowercase letter I with a dot on it, and we have an uppercase letter I without a dot. So if you're English or Norwegian and try to capitalize Nils, then you get Nils without any more dots, and vice versa, of course. But if you try to do the same trick in the Turkish or Azerbaijani context, you get something completely different. You get you basically have one I that has a dot always, and another I that never has a dot. And while I was preparing for this, I found something interesting on Wikipedia, on the dotless I, and it's handled problematically in the Turkish locales of several software packages. It has effects not foreseen by application developers by doing automatic upper and lower casing. And I think this is very beautifully understated, because at Microsoft, Turkish is one of the languages that we always test first, because problems, always problems. What else we have? Yeah, this is how you properly spell the name of the largest city in Turkey, and I managed to avoid saying capital of Turkey. Yes. Then something occurred to me today, names and initials for names. As you can see, this is a snapshot from my Outlook for Android, and the second one from the top has a picture in it. That's the picture of my boss, Alex, drinking beer, which he usually does. And the other two, they don't have pictures, so we just substitute their initials instead. But that can actually be, I don't actually know what Outlook does when confronted with a locale where you have, instead of given name first, you have a family name first and given name afterwards. For example, there is a fairly well-known computer graphics technique known as Phong shading, named after somebody named Phong, but that's actually his first name. He was from Vietnam. So I'm not sure if that would end up correctly in those locales, and I have even less clue what they do in China, where the concept of an initial is sort of vague at best. Dates. What date is this? It's actually not possible to tell without context. You have to know which locale you are in. So it could be the 5th of August, or it could be the 8th of May. So dates are hard. Anything that involves dates or timestamps or time zones or calendars, if you can avoid having anything to do with it, then don't have anything to do with it, because that stuff is really hard. If you must have something to do with it, then make sure that you always serialize and deserialize timestamps in a non-culture dependent format. And one of the benefits of having modern UIs is that instead of actually writing text in a text field and then trying to parse it, you can use customized widgets, for example, for date input, and then you know exactly what you get. You don't have any ambiguity as to whether this is the 5th of August or the 5th of May. Next up, numbers. We have decimal points in various formats. We are used to the comma in Norway. We have the period in English. Then we have grouping. We don't group the fractional part of a number. If you write the digits of pi, then you just write each digit after the other. But there are cultures where they actually do that. And on the whole number part, we do group. We group by thousands. And that's actually quite common. But not everybody does that, as you can tell from the example from India. And there are actually more weird ways of doing this than you might think. And if you have groups, then you have a grouping separator, which can be various things, typically period, comma, or spaces. The one thing you never have is if your decimal point is a period, your thousand separator is not a period. It's the other way around. And yeah, about the decimal point, I read that some places in Switzerland, they use the period as a decimal point when they deal with money, and the comma when they deal with any other number. And that's even stranger, if you ask me. So here's the list of various ways of grouping digits. You can see most of the, A to E, they are grouping by the thousands. And D and E don't actually concern us because they're just handwritten forms. And we don't do handwritten forms on computers. But the next one is interesting. We have the concept called a myriad. And in Norwegian and English, a myriad just means a lot, many. But it actually comes from Old Greek and means 10,000. And in East Asia, they typically group by tens of thousands. So that in Japan, you might find digits grouped by 4. But even though the numbering system groups by tens of thousands, they also use grouping by 3 when they write the numbers, as they do in China. So that has to be slightly confusing, I think. And then you have this truly weird case in India where you have a thousands group at the beginning, and then you group by the hundreds afterwards. I don't know who thought that was a good idea, but that's what they actually do. So whenever you need to format numbers, you should use libraries, library methods, library functions. If you have to do any formatting by yourself, there are usually APIs available that will let you retrieve meta information about how the groupings are built and which characters you use for what, and so on and so forth. Yes, so that was currencies. I almost forgot. We have all the different symbols that we use for currencies. Some are specialized symbols, some are just abbreviations like the kroner. And they end up in front of the number or in back of the amount or with or without an intervening space. The negative numbers are specified in different ways and so on. So again, use libraries when you can. Use some meta APIs when you can't. Next subject is localization and localizability. So I'll go through how we do localization. I'll talk a little bit about what to localize and what not to localize. We have what are the pitfalls of localization. String pasting is particularly pernicious. It's actually possible to over-localize, which I'll show you an example of. And then you have some particular challenges with, for example, what we call CJK, the Far Eastern languages of China, Japan, and Korea. So this pair of characters, that's Chinese, and it means Chinese in Chinese, according to Google Translate. And what distinguishes the writing system of China is that it's ideographic, and they have thousands upon thousands of characters, which is quite different from what we do, and one of the reasons Unicode came into being. You may know that Japan co-opted the Chinese writing system once upon a time and started using it. So if you read out these same two characters in Japanese, they read kanji, which is the name for that particular script in Japanese, which is basically stolen from the Chinese. But everything in Japanese couldn't be represented by that. I can't call it an alphabet, it's an ideogrammatic thing. So they invented something called hiragana, which is basically a syllabary that has 48 basic syllables, and with embellishments you have something like 108 different syllables, which are all the syllables you are allowed to use in Japanese. You can't write Japanese if you use something else. So a loan word such as beer, you can't write it, so they change it to biru, just to be able to have a syllable that is in the syllabary. And for some strange reason, they later on made a simplified version of the same syllabary. They are completely parallel, but they're sort of used for different things for cultural reasons. But if you look at the two last characters of each one, the kana part, you can see that the rightmost one is a simplification of the leftmost one. This is Hangul, which is the writing of Korea. It looks like it's similar to the Chinese system, but that's actually not the case. Each of these blocks are made up of individual letters in an alphabet. And then, I'm running my presentation off her box right now, and that precludes me from doing a small demo I was going to do, so I'll just tell you about it. This is Arabic, and this is Hebrew. So their distinguishing feature is that they are written right to left, so everything is mirrored. And if you paste this into a text editor, for example, the one that you have in PowerPoint, and you start at the left-hand side and arrow to the right, then you go like this until you get to here, and then you pop over there, and you continue arrowing right, then you go this way, then you go there, and you pop back there, and you go this way, and you go over there. So if you want to make software that uses both right to left and left to right languages and can mix them properly, then you have a job ahead of you, because that stuff is really, really hard. I'm going to talk about a tool called PseudoLoc, which is very useful for verifying that you've done sensible things with localization. And pluralization, which is also a surprisingly difficult subject. So how do we localize stuff? We, for example, this is a bit of a UI from an Android application, and it has a hard-coded string in it. The button text says open activity. So to make this localizable, we just extract that string into a different text file, an XML file, and reference it from the UI code. So the actual resource file looks something like this. And once you have done that, you have done the localizability part. Then you have made it possible to localize this program into a different language. Because then you end up with a tree structure like this. You have one default XML file, which is typically US English, at least for us. And then you have, in a different subfolder, you have one for Bulgarian, you have one for Catalan in this case. And then you can choose, you can distribute the whole thing so that your users can change the language on the fly on their computers if necessary. Or you can package each one separately and sort of distribute just the languages that the individual users want to have. It's also possible to localize things that are not strings. It could be culture-sensitive images and so on. And at least the way we do it in Microsoft, we send this stuff off to third parties to translate, and then we get things back. And we are not always impressed with the quality. So one thing we can do is to add comments wherever we can to make it easier for the actual localizer, the one who understands the native language, to figure out what is actually meant. In English, the word update can be a noun and can be a verb. And then we can specify in a comment that this is a verb, so that because it might be a different word in different languages. And we have another approach to quality assurance. We have something like 30 different nationalities working in Oslo. So there's always somebody who knows some language. So we have people who actually know the domain, go over the app and test that everything is good. Yeah, PseudoLoc. That's a tool that can be used to test the localization of an app. So it just takes the file of resource strings and mangles it. Sort of prepends markers to the end, start and end of each string, and then can do different stuff as well. And you can maybe change left to right to left to see how that works. You can do that even if you're not actually having an Arabic or Hebrew or whatever interface. Actually, the Arabic alphabet is not used just for Arabic. It's also used for Iranian or Farsi. And somewhat to my surprise, it's the first alphabet ever used to write Afrikaans, which is the Dutch version spoken in South Africa. But that's completely beside the point, but it's kind of interesting. So what it looks like is something like this. We change the resource file where it says feedback. We have taken a couple of characters at the front and the back to serve as delimiters, and we take these from a completely different character set just to verify that the application can handle those character sets. And then if you want to, you can mangle all the characters in between as well, which I think is fun, so I do that, but you don't have to. It's more readable if you don't. But it's a very easy tool to make. You just gobble in an XML file and spit out another one. And at this point, I was going to do a small demo, but since we couldn't connect this box to that screen, and the demo is on that box and not on that box, and we don't do the demo, but it's not a big deal. I have slides that will show what I want to show anyway. But the digression I was going to do before the demo is to talk about feature flags. That's another tax that we pay, which nobody actually has to pay. This is completely voluntary. But when we develop new features, we don't ship them to all new customers all at once. We sort of try them out in the small to start with. And then we have feature flags that says, should this user have this new feature or not? And we couple that with the concept of rings that we sort of expand. We start with the first team that gets to see the new functionality would be the feature team itself, the people working on the product. The next might be Microsoft in Norway, and outside of that, there might be all of Microsoft. And we like to have things cook a bit in each of those rings before we send it to the next ring to verify that we didn't make any screw-ups, because we sometimes do that, I'm sorry to say. And we can also target specific audiences if we want to. We can also use this with A/B testing. basically we can have a certain subset of users based maybe on a hash of their user ID, get the new feature, then we can get the rest of the users get the old feature. And then we can, if we have telemetry in place, we can actually see if this is an improvement or not. So that was the end of the digression, and I was going to show you an app where I have access to features that you don't, even though you can install the app if you like, but those features are only for the feature crew, so of which I am part. But anyway, what can PseudoLoc tell us? It can tell us if we have hard-coded resources or under localization. Do we format strings properly, or do we do token pasting or string concatenation? If you look at the code sample here, the first one concatenates two strings, concatenates the number with the trailing string, and that can be localized in some languages, but almost certainly not in all. Whereas if you do it properly with a formatting string with a placeholder, then you can easily change the order of things. You can have words before, after, whatever. Do we handle longer strings gracefully? You'll note that the PseudoLoc thing made strings longer than they used to be. This is actually not as much of a problem now as it used to be, because in the olden days of Win32 programming, you usually had a fixed grid where you had your layout, and you did your UI and everything looked good, and then you translated this into German, and then suddenly everything got clipped at the end, because German tends to be longer. But even so, it's good to verify that even with an adaptable UI, it's good to verify that it actually will make longer strings fit, because some languages are longer. And rendering all the character sets correctly, that's why we like to have some characters in there from completely different character sets. It's actually possible to over-localize as well. I'll show you one example of that eventually. There are some things that PseudoLoc cannot tell us. It cannot tell us if the texts are any good, unfortunately. And if there are problems with images or icons, it can't tell us that either. But here is an example of a missing translation that we can easily discover when you run this application in a PseudoLoc locale, because you get all these strings that are mangled, and you can see that the include email address string has not been mangled. So that means it's not a resource. It's basically hard-coded into the app, and therefore you have to go back and fix that. Then you have string concatenation. If a different language wanted to put that link somewhere in the middle of the string instead of at the end, that would make translation quite hard. And the reason why this one ended up like this is because we have a hyperlink, which is a different widget from the text widget. So if we actually want to solve this properly, which is what we ended up doing, then you have to write code that would generate a more complex widget for you on the fly, programmatically, which is a lot more work than just putting strings into a table. But sometimes you have to do that. Here is a similar one. You can see that the number 163 should have been part of the, should have been formatted inside the string if we had a placeholder, and we don't have a placeholder. And in this case, it's because the number has a different text size. And in this case below, it's because the name has boldface on it, which would also require us to actually write code to generate a widget with 2 text bits or 3 text bits, and we need to locate the placeholder and blah, blah, blah. So it's a lot more work than this. Yeah, final string concatenation. If you are Yoda, you would want to express this differently. But it's basically the same as the former examples. Here's an example of over-localization. You can see at the bottom of the card, it should say actually the name of a day, which it doesn't. This is what the resource looks like. The 4Ds just signifies date formatting, that we should have the name, localized name of the weekday. And if we mangle, I feel like I'm missing a slide here, but what happened with PseudoLoc is that it mangled the letters inside the 4Ds, so it was no longer 4Ds, it was for something else. So this wouldn't be a problem if none of the localizers actually change the string, because then it would still be DDDD, which works in all languages. But this should probably not have been a resource in the first place, because it sort of invites trouble. Hard-coding app name in a string, that may or may not be a problem, depending on whether you want to translate the app name or not. If you have any questions along the way, please feel free to raise your hands. And just be aware that you see me better than I see you, because there are lights. Yes. What not to localize? Usually we try to stay away from localizing server-side log messages and that kind of things, logs in general, because we sort of assume that most sysadmins understand English. And but sometimes I'm surprised. I once installed the German edition of Visual Studio with the German edition of .NET, and it turned out that all the exception messages were now in German. So that was a bit of a surprise to me, but fairly impressive. We try not to do that. Okay, next subject is pluralization. Back in the old days, the Windows File Explorer used to display the number of items selected like this, which I can see some people remember. It doesn't do that anymore, but it used to do that. And it sort of bugged me, because I was young and stupid and thought it would be very simple to just fix it by something like this. You can just prepend an S if it was not 1, because grammatically in English 1 is singular, everything else is plural. But of course it turns out there was a reason they cheated. This is actually a very hard problem. Yeah, I lost my monitor, but that's okay, I can watch over here. For example, even in English you have irregular plurals. One woman, two women, or sheep, one sheep, two sheep. If you try to apply the same rule to those examples, it will be wrong, and that means you can't generalize it. In German, you change not just the plural case of the noun, but you might change the verb as well. So, eine Datei konnte nicht gelöscht werden. One file could not be deleted, but two Dateien konnten nicht gelöscht werden. So you have to change it in two places. And this is just a start, because if you go to Polish, you have one case for the singular, then you have one case for 2, 3, and 4, and then it's suddenly a different plural for 5. And this has something to do with the genitive case, but I don't actually understand Polish very well, so jeden plik, that's one file, dwa pliki, 2 files, and pięć plików, 5 files. And there are many different ways of dealing with this, but the most elegant or the most understandable overview I've seen comes from Mozilla and Firefox, where they have taken all the languages that exist and divided them into plural rules, 16 different plural rules. And within each plural rule you have one or more plural form. And just to show some examples of that, Rule 0 is what you have in the Far East languages, like Japanese. You don't really have a plural, you just 1 file, 2 file, 3 file. So that's very simple. Then you have that was rule 0. Rule 1, like Germanic languages, it's true for English, it's true for Norwegian. You have 1 is singular, everything else is plural. But even then you can have irregularities like women and so forth. And then you have a whole bunch of different forms of varying complexity. If you look at the Slavic languages, they all have some kind of issue with 2, 3, and 4, but they are different issue for each language. So you have 4 different rules for Slavic languages that deal with mostly 2, 3, and 4. But they also have 3 or 4 different forms. So there's one of them that's even more complicated. I have a list in my bag if somebody wants to see it afterwards. Rule 15 is sort of interesting. It's Icelandic, which is a bit of an outlier. It's exactly like Norwegian, except if things end in 1, it's singular anyway, except if it's 11, because then it's plural. So why they ended up there, I don't know. And the one with the most forms I found was Breton, 6 forms. So I don't want to learn that language. Thank you very much. So an example of how this might work, if in Polish, then you have to provide 3 different forms for every word that you translate. So we have seconds, minutes, hours, and days. So the next column is singular. The second is the plural you use for 2, 3, 4, and 22, 23, 24, and so on. And the last one is everything else. And one downside to this is that it makes stuff a lot more complicated for localizers. They have to understand this. And that's not necessarily easy. Luckily, most of the strings that we have don't have any numbers in them, and they don't require pluralization. So this only applies to a small subset of all the strings that we have in the application. Some sample usage. This is from a test code, actually. Just verifies that it has all the right plurals for everything. And if you're a bit stumped by the string.localized, this is a C# extension method. So it's actually a static method that takes the string as the first parameter and the number as the second parameter. And the string is a resource identifier. This is just one way of creating confusion if you as a programmer. Let's see. I'm actually a bit behind schedule here. Next thing is accessibility. That's all the stuff we do to cater to people with disabilities of various kinds. The one I'll be spending the most time on is the visual one, where you have people who might be completely blind, they might have impaired vision, they might be colorblind. Hearing, deafness, and hard of hearing. I've never done anything that involves sound at all, so I don't have much to say about that. I can say one small thing about people with poor motor control, or drunks, as we call it. Some of the things that we can do to make life easier is to actually increase the size of touch targets and things like that. And that actually helps normal users as well. So that's one thing to keep in mind. And then we have cognitive disabilities, learning disabilities, and focusing problems, and so on, and being drunk, of course. And before I dive into the visual stuff, I'll just show you a short excerpt from something I found on the net that describes your typical developer. And even though developers tend to be pretty smart, that's not their distinguishing feature. I mean, it can be bright as hell, but if you don't have the ability to absorb, retain, and reference large amounts of meaningless detail, trusting to later experience to give it context and meaning, then you won't do very well as a developer, because that's what we do. And by now, I'm sure half of you have read the entire thing. And that makes developers perhaps not the best people to create user interfaces for people with cognitive disabilities. So I'll just remind you of the title of a book by Steve Krug, where the title says more than most books. Don't make me think. If you just keep that principle in mind, that should help quite a lot. Okay, visual disabilities. Blindness. If you are completely blind, then you are dependent on a screen reader, which will actually read the text on the page to you. And that often means that you also have to have keyboard navigation, so you can tap from one control to the next. And that means that all functionality in your program must be accessible through a keyboard interface, which can be a bit of a challenge. And making the screen reader make sense can also be a bit of a challenge. I mean, there is a lot of support for this out of the box in modern systems, but even so, it's very easy to get into problems, especially if you might make a lot of custom controls yourself. There's one upside to this. When you do things with a screen reader, you often have to assign accessibility IDs or something to individual widgets, and these can be reused in unit testing, so you can use them to drive your actual UI in testing, which is good. I believe, well, I expect you all have some sort of smartphones. So a fun experiment is to take it out and go to settings and just turn on the accessibility features and see what it does to you. It's quite interesting. I would recommend you try that. Impaired vision. That's basically a couple of things. We do high contrast variants of the UI for people with poor vision. And for such people, it can be very difficult to distinguish, to tell that a gray text is gray because the system is trying to tell them something or because their eyes are not working properly. So that's why we have high contrast and why we don't use animations in those cases. And this is an example of what a high contrast interface can look like. This is one of the several standard ones included with Windows. You have one white on black, one black and white, and a couple with different colors. And people pick the one they want, or they customize their own. And this is very, very far removed from what my designer drew up. He doesn't like this at all. So aligning this with what our graphical designers do can be a bit of a challenge. And one way of approaching that is, well, as an example, how to handle borders. First of all, try to align all your design colors with the system colors, because you have a whole long list. The power went out. I have sound? Okay, I have sound. That's something. What was I talking about? I can just this one actually requires an illustration, so I'll... Borders? Yeah, borders. It's kind of hard to talk about borders without having a picture. But I can skip ahead and talk about color blindness. I was on a safari in South Africa a couple of years ago with my brother. And we were driving around in the Kruger Park in an open car with a guide and looking at lions and giraffes and all kinds of things, which were very good. And then the guide drove up to a bush, and the bush had berries on it and said, "You have to taste these berries, they're quite good." And my brother picked a berry, and the guide said, "No, not that one, that's green, it's not ripe, pick a red one." And he dropped the berry and picked another one, green. And by now you might have guessed that my brother is colorblind, so he really couldn't distinguish between the red and the green berries. And the really interesting thing is that our fellow passengers thought he was joking. They couldn't believe that he couldn't actually tell the difference, but he can't. So what that goes to show is it's not that you can't use color in your UI. You can even use color to distinguish things, as long as that is not the only distinguishing feature. So you have to add something else. And I have slides with samples of these, but the slides are currently dark. Yeah, okay. Yes, okay, let's take one step back and go to the borders. This is what our designer gave us. It is a button without a border. That's fine, because the button face itself doesn't need a border. It's certainly distinguishable from the background. But if you apply high contrast setting to it, it ends up maybe like this, and it's no longer obvious that this is a button. It looks like some kind of text maybe. What do I know? So one solution to that is to actually add a border with a logically different color, which is physically the same color as the button face. And then in the high contrast scenario, you just change the physical color corresponding to that other color, and you have what still looks like a button, and it looks the way it should in high contrast mode. And that's basically why you want to stick with the enumerated system colors that you have on all platforms. So there is a color it says this is the button border color. Use that one, and you can map it to whatever else you like in your designer's design, but make sure it goes back to what it should be when it's high contrast. Yeah, this is just an illustration of our car in the Africa with the game warden, our guide. And this is during the afternoon break. This is not the berries. Here's an example of an excerpt from the London Tube map. And on the left-hand side, you see this one basically uses only color to distinguish the different lines. And on the left-hand side, you can see the map as it's supposed to be seen, and on the right-hand side, you can see it as it might appear to somebody who's colorblind, one way or the other. Is there anybody who see them as the same? No? Okay. Good for you. As another example, if you use only color as the distinguishing features, how about this one? Is this different to everybody? That's not almost surprising. Should have been at least one that was colorblind. But what you do to fix it is, of course, to add something else. So it's okay to use color to distinguish things, as long as that's not the only thing you use. Okay, we'll talk a little bit about telemetry, which we use to get feedback from users. I like this feature, I hate that feature, I have this idea for new features. We use it for crash reporting. If the something goes bad, then we need to know why, preferably with a good stack trace. And we do quality of service monitoring. Say we have a scenario like page load. Does it work? If so, how long does it take? And we can see which features are being used and things like that. We can use it in A/B testing. So you might write code that looks a bit like this. It's a C#. You wrap all your code in monitoring code. So you basically say that this scenario succeeded or this scenario failed in case of a failure. And if you're not used to C# and the using statement, it's basically a wrapper around an interface that has a dispose method. So it does that in the finally clause. So that basically means if the dispose method is always called. There might be exceptions that you find acceptable, file not found maybe, that's okay. Or if you're trying to download a resource over the net, if you don't have a network connection, then obviously that's not your fault and there's nothing your program can do to fix it. I'll just skip over that one. That's the implementation of the monitor class, a very simplified one to be sure. But this kind of code is not too hard to write. But if you look at the usage, you can see that the highlighted line of code, which is the only actual line doing anything, sort of drowns in all the scaffolding surrounding it. And that's a bit of a problem with monitors like this, especially if you have more complex scenarios with sub-scenarios and blah, 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 and you have to really hunt to find the actual functionality of the program. So we have some people who have been experimented with an attribute-based approach, where you map scenarios to methods and you just apply attributes instead, and that's actually much nicer. One thing about logging is privacy. User identifiable information is something that is definitely a no-no, and we try really hard to keep that out of the logs. I mean, if whenever there's a leak of that kind of sort, then the engineer on watch is called in the middle of the night if necessary and told to go fix it or turn off the service or whatever, but mitigate the problem. And seeing as I have 5 minutes left, I have actually come to the end of the most interesting parts. There are some taxes that I don't think are as fun, so I put them at the end in the hope that I wouldn't have to talk about them, and then I'll take that one, which may or may not be a tax. It's a fairly new concern. But if you're used to selling to market, this is especially for mobile development, but if you're used to selling in markets in North America or Europe, you can expect that people have decent devices, you can expect that they have decent network coverage, and so forth. But if you're selling in, say, India, you can expect that they have not so good devices, and their connectivity is slow, and it's usually metered, so it's expensive. And you have to think about how to deal with that if you want to reach that market. And that's what Twitter has actually done by making a custom version of Twitter, which is called Twitter Lite, which is very small. It uses as little networking as possible and so on. So the ideal thing would be to have a single app that actually adapted dynamically to differing conditions. You can sort of set parameters for what goes on here. So we have a couple of minutes. Any questions? If anybody wants to come work for Microsoft, you can talk to me or send me an email. We live a few blocks from here. And then I have one final thought, and that is that all of these things tend to be much more expensive to retrofit than to implement from the start. So it's a very good idea to find out ahead of time when you start on a new project what are the requirements. Because you don't want to do things you don't have to do, because it's costly. But if you can find out what the requirements actually are, then you can plan ahead. Thank you.